that if you have log of a quantity raised to a power, that power is allowed to go in front as a factor. So the new equation is natural log y equals natural log of x squared times natural log of cosine x. Do we remember this property? Yes? No? Do you want me to refresh your memory on this property or write it again? Do you want me to refresh your memory on all properties of logs? The three properties? We already refreshed our memory on the change of base formula. Do you want me to refresh your memory on the other properties?
Yes, please.
Okay, so there are three properties. I'm going to come back here. Maybe I'm not going to come back here. So let me write them here. Properties of log in any base. So here's one property. Log applied to a product. This is log of A plus log of B. If it's a product inside, then it can be changed into, of course, in any base, natural log, but it has to be the same base, of course. If this is natural log, these are natural log. If this is log base 3, these are log base 3, and so on and so forth. So this is the first property. The second property is applied to a quotient. Log of A over B is the same, but with minus. It's log A and log B. That's the second property. So let me call this 1, let me call this 2. This is the product and this is the quotient. And this is the last one that we just used here. Log of A raised to power little b. Little b goes in front as a factor, which means multiplies, not addition, subtraction, multiplies log A. And this is the power rule. Quotient, power, product. So then I'm going to copy where I left off, from where I left off. Natural log y equals natural log of x squared times natural log of cosine x. So I'm applying the third property by removing or changing the position of this as a factor. It becomes a factor in front. It multiplies all this quantity, and that's what we did. Now and only now, which step am I on? So this was step 1. I simplified as much as I could, and now step 2. I differentiate. I'm applying this procedure or this operator to both sides. So now let's focus on the left-hand side. How do I differentiate this? So this is natural log of a function. Can anyone give us this piece? It's okay if you're wrong.
1 over y
times dy over dx. Awesome. Excellent. That's it. Great job. So this is the left-hand side. Done. Now on the right-hand side, a product. Function 1, function 2. When I differentiate, I know that this has to be a sum. Can anyone differentiate this for us? So I put it here. And then times natural log of cosine x. But I have to differentiate this first.
1 over x squared times 2x.
Very good. Times 2x. Awesome. 1 over the function times the function prime. I'll come back. We'll simplify it. Plus. Now I copy the first function. Can anyone give us this function prime? So I can put it here.
1 over cos x times negative x.
Times the inner function prime. Awesome. Now you can say, what's all this? How do I? No problem. All we have to do is multiply by y, both sides, to get this derivative. What will be this derivative? it will be the derivative of this, which I could not directly differentiate. I had to apply log first to both sides, remove this power, change it into a product, and then differentiate implicitly. Okay, so let's clean this up first in one step. So I'm going to write it one more time. 1 over y times dy over dx. Here, of course, I will simplify one of these x's. Then I have 2 natural log of cosine x divided by x. Then plus, or I should say minus. I know that sine over cosine is tangent. Why don't I put it in front? Tangent x times natural log of x squared. All I have to do now to find dy over dx is multiply both sides by y. All this, 2 natural log of cosine x over x minus tangent x natural log of x squared, multiplied by y. I'm not going to write y here. It's a waste of time. I'm going to write this. Cosine x raised to natural log of x squared. And this is it. There is no direct way of differentiating. There is no direct way of differentiating a function raised to a function. If it's a function raised to a power, very straightforward. N f to n minus 1 times the inner function prime. But once I have a function raised to another function, I have to go into a roundabout way. I have to apply natural log to both sides. I have to simplify the equation as much as I can. And then I will apply the operator to both sides. Like I square both sides or differentiate both sides. I'm allowed to do that. And differentiate implicitly. The left-hand side, 1 over y times the inner function prime, because this is a function, equals this prime, 1 over the function times the function prime, times the second one, plus the first one times the second prime, 1 over cosine times the inner function prime, which is indeed negative sine x. This is negative tangent. I copied this function. I simplified a little bit here. So this piece is this. And now dy over dx, I need to multiply both sides by y. What is y? Cosine raised to natural log of x squared. So let's take a moment and look at this and see if we have any questions. Any questions on this? Anything? Before we look at a couple of examples. I let you choose. X to 1 over x, x to sine x, the square root of x raised to x. These are not functions raised to a power. They are functions raised to another function. Sine to natural log, x to natural log to cosine. So let's choose one more and go through the process again. These are nicer functions than what I chose. Anyone? If not,
52.
52. So let's look at 52. So we have in 52, we have y equals, watch me copy something else. I do that a lot, the square root of x raised to x. So keep an eye on what I copy. As you know, my device is 3 feet away from me. No excuse. Okay. I am asked to find the derivative of this function. I know that this is a function raised to another function. I have to go into a roundabout way and first, in number 1, apply natural log. Can anyone tell us what to write? The left-hand side, you are going to say natural log y. On the right-hand side, you also have to say natural log of the same thing. It's safe to write the first step first. Okay, in step number 2, how will you simplify this a little bit? Because we have to. We can't differentiate in this stage.
bring the exponent to the front.
Yes, as the power, as a factor, the power as a factor, yes. Natural log the square root of x. It's all done. In step number 3, I'm ready to differentiate. Well, what do we write on the left-hand side?
One over y over x.
Very good. The x, and now I have to be careful because this is function 1 and this is function 2. So I have to use the product rule. I differentiate the first and I get 1. Nice. So then natural log the square root of x plus I copy, and now I have to differentiate this. Natural log of a function prime. Natural log of a function prime. What do I write?
One over the square root of x.
Times the square root of x prime.
Times 1 over 2 x root x.
That's it. Times the inner function prime, which is 1, so I don't have to do anything. Awesome. So now I have to clean it up. So in step 4, let's clean it up a little bit. 1 over y, dy over dx. The first piece is very clear. But look what happens here. When I multiply the square root of x by the square root of x, what do I get?
X.
Good. And I have an x at the top. X from the top simplifies with x from the denominator. Final step. I just want dy over dx. How do I get dy over dx? From this equation. What do I need to do to both sides?
Multiply by y.
And here's my y. That's it. No one can or should even try to do anything else. Okay, what I wanted to finish this section with, as you know, we have 6 trig functions, like sine, cosine, tangent, and the other 3. So we also have 6 inverse trig functions. Yes, we have 3 more here, but I'm only interested in the inverse of this, the inverse of this, and the inverse of this. This one being either sine inverse of x, which is not 1 over x, is arc sine x. This one, which is cosine inverse of x, which is arc cosine x. These are the same notation, same function, different notation. And this one is tangent inverse, the inverse of tangent. And the same thing with arc tangent x. So I'm going to share my screen for a second and just show in here the keys. So sine with sine inverse, cosine with cosine inverse, tangent with tangent inverse. So this is not this power of -1. This is the inverse function of tangent, and it's activated with the second key. Okay? Good. So now I would like to discuss their derivatives. They have to be carved in stone. These are basic functions that we really need to remember. Even if it's open notes, open book, we still need to remember the basic functions. Very important. So the arc sine x prime, the arc cosine x prime, and the arc tangent x prime. I normally avoid this notation, even typing. For me, it's, of course, it's easier to type this than to put the power. And secondly, it could be confusing, but it's a very important notation. You see, the calculator doesn't use this, use that. It uses this. Okay, so arc sine and arc cosine are very similar. 1 over the square root of 1 minus x squared. This is identical, but it has minus in front. So when we differentiate the inverse of sine, we get this. When we differentiate the inverse of cosine, we get the same thing, but with minus. And the arctangent prime is 1 over 1 plus x squared. These should be carved in stone. And of course, you can say, yeah, you forgot something. Yes, you could say that. There is no need because it's 1. But what if I have arctangent of the square root of x squared plus 1? How will I differentiate that?